Hi, I'm Courtney Miller, and today's date is January 16th, 2026. This video explains how I solved combined spectral problem J. In this problem, I was given IR, proton NMR, and carbon-13 NMR spectra for an unknown compound. My goal was to analyze all of the spectra together and determine a single structure that fits all of the data. The molecular formula for this compound is C10H12O. To calculate the degrees of unsaturation, I use the formula degrees of unsaturation equals C minus parenthesis H over 2 parenthesis plus 1. So this calculation would be 10 minus parenthesis 12 over 2 parenthesis plus 1, which equals 5 degrees of unsaturation. 5 degrees of unsaturation suggests the presence of a benzene ring, which accounts for 4 and 1 additional unsaturation, which is consistent with a carbonyl group. The IR spectrum shows several key peaks. At 3030 Cm-1, there is an aromatic C minus H stretch. Between 2950 and 2850 Cm-1, there are alkyl sp to the third C minus H stretches. At 1715 Cm-1, there is a strong ketone C equals O stretch. Finally, peaks at 1600 to 1500 Cm-1 indicate aromatic C equals C skeletal vibrations. Together, these peaks indicate the presence of an aromatic ring and a ketone functional group. The carbon-13 NMR spectrum shows 7 distinct signals which indicate symmetry in the molecule. At approximately 208 ppm, there is a carbonyl carbon of a ketone. At 141 ppm, there is a quaternary aromatic carbon. Signals between 125 to 130 ppm correspond to aromatic CH carbons. At 45 ppm, there is a CH2 carbon alpha to the carbonyl. At around 30 ppm, there are signals for a benzylic CH2 and a terminal methyl CH3. These carbon environments support a phenyl substituted ketone. As you can see here. The proton NMR spectrum shows 3 major signals. Between 7.1 to 7.3 ppm, there is a multiplet integrating to 5 hydrogens, which indicates a monosubstituted benzene ring. Between 2.7 and 2.9 ppm, there is a multiplet integrating to 4 hydrogens, which corresponds to two adjacent CH2 groups. At 2.1 ppm, there is a singlet integrating to 3 hydrogens, which represents a methyl group attached directly to the carbonyl carbon. The integrations add up to 12 hydrogens, which matches the molecular formula. Based on all of the spectral evidence, the proposed structure is 4-phenyl-2-butanone, also known as benzolactone. This structure contains a phenyl ring, an ethylene bridge, and a ketone group. It accounts for the molecular formula, degrees of unsaturation, IR functional groups, and all NMR signals. In conclusion, all of the provided spectral data are consistent with the structure. 4-phenyl-2-butanone, and no peaks remain unaccounted for. I thank you for watching.